Here we are on the edge of the Arctic ice sheet, 81 degrees north of the equator and 17 degrees east of the prime meridian. It's June 19th, 2022, 3 days before the summer solstice and in the midst of the Arctic summer, during which the area experiences 24 hours of sunlight. We are 48 kilometers or 30 miles north of Svalbard, a group of islands governed by Norway and centered east of Greenland and northwest of Norway. 60% of the islands of Svalbard are covered by glaciers. Glacier is a term we use to describe ice found on land. When those glaciers reach sea level and break off, they produce icebergs, which float atop the ocean surface. Sea ice also floats atop the ocean surface, but it forms from the freezing of seawater. The Arctic ice sheet is a large connected region of sea ice that covers most of the Arctic Ocean. It grows larger from the freezing of seawater in the winter and shrinks as it melts in the summer. The sea ice we see here is further classified as pancake ice. The name comes from the shape, which is produced as ocean waves break apart the edges of the melting ice sheet. Those pieces are then continually pushed apart and back together with the waves. They also melt and freeze with the changing temperatures. The result is this pancake shape. When it's winter, the sea ice in the Arctic grows across and attaches around most of the land masses, fastening onto the edges of the land. Thus it gets the name fast ice. The islands of Svalbard are almost completely surrounded by fast ice during the winter. The polar bears that live in Svalbard rely on this fast ice as a method of transport to move around the edges of the island and hunt seals. When the sea ice retreats in summer, it detaches from the land and drifts with the currents and then gets the name drift ice. Land animals who depend on the ice will have to drift with it during the summer or find alternate food sources. It's summer in Svalbard and the ice is retreated. So these polar bears are scavenging for food and found a whale carcass that drifted up onto the shore. This time-lapse animation shows how the Arctic Ocean ice sheet has changed since 1984. We can see how the ice grows and shrinks with the seasons, how it shifts around with the currents, and how it has shrunk in overall extent over the past 38 years. The ice thickness and age also vary across the Arctic ice sheet, from a few inches of new ice on the edges to as much as 4 meters or about 12 feet of thick older ice in the center. The thickest ice has survived for 4 years or more without melting. The oldest sea ice is represented in this image by the white color and the youngest blue. In mid-March 1985, the left image, the winter maximum ice pack was dominated by ice at least 4 years old. In 2021, the right image, only a small strip of very old ice remained tucked up against the islands of the Canadian Arctic. More than half of the winter ice pack was less than a year old. The movement of the ice as it drifts is determined by the currents of the underlying water, which move anything that floats atop the water, including not just ice but also driftwood and garbage. Svalbard sits along the route of the transpolar current, which crosses from northern Russia to the North Atlantic Ocean. Therefore, the islands on the north side of Svalbard are places where a lot of this debris collects in the summer, plenty of opportunity for beach cleanup. What are the main global impacts from a shrinking Arctic ice sheet? Polar ice reflects light from the sun at a rate much higher than seawater or land does. As the ice begins to melt, less sunlight gets reflected into space and instead is absorbed into the oceans and the land. This makes the overall temperature of land and water rise, which can then cause even more melting. Warming ocean and land temperatures means organisms will migrate, and the species found in a given ecosystem will change. A larger area of the Arctic Ocean is appearing ice-free during the summer, and that means a larger summer population of microscopic photosynthetic plankton that fuel the bottom of a food web. Marine life in the Arctic Ocean waters is growing in population and will continue to do so, albeit with new species adapted to the warmer temperatures. The waters of the Arctic Ocean also contribute to the mixing and circulation throughout the world's oceans. As the Arctic Oceans warm, the surface and deep water currents that they feed will also warm, which will impact ecosystems and climate patterns across the globe. Does a shrinking ice sheet impact sea level globally? Not directly. Ice that floats atop the water, whether it's sea ice or icebergs or ice in your water glass, will not impact sea level when it melts. In contrast, the melting of glaciers, ice on land, does cause sea level to rise, and glaciers throughout the Arctic, especially those in Greenland and Svalbard, are melting and contributing to global sea level rise. The warmer climates and ocean water of an Arctic Ocean with shrinking ice cover will increase the speed of glacial melting around the Arctic. What's sea ice made of? During the freezing process of seawater, only the water molecules turn to ice. The salts that were dissolved in the seawater are left behind, making the remaining water a bit saltier than normal. Some of that salty water gets trapped in pockets inside the newly formed ice. These brine pockets are distributed throughout the ice. Some will escape, but enough remains that you wouldn't want to drink or eat this ice.